In this section, we're going to look at the solution to the pyramid problem by using recursion. Before we get started, quick pause. I want to tell you, if you had any difficulty with the recursive solution to the steps problem that we worked on just a little bit ago, I really encourage you to give a shot at doing pyramid on your own with the recursion solution. Because you essentially already know how the recursion solution is put together. All you really have to change is some of the bounds, or some of the essentially the range of numbers that we're considering with this new solution for pyramid. So this would be a great opportunity to practice some recursion related stuff on a problem that you're already kind of familiar with. Now, if you already gave it a shot, or if you don't want to, whatever it is, no problem. We're going to go through the recursive solution right now. So as usual, we're going to make a backup of our pyramid function. So I will copy the whole thing, go down the bottom, I'll paste it. Here it is right here, and comment it out. I'll then go back up and I will clean out the pyramid function. So now we've got only pyramid and the export statement right here. All right, so in general, the recursive solution is going to look very similar to the recursive solution for the stairs problem. So the first half of this, we're going to speed through pretty quickly. And then as soon as we start getting into some pyramid related stuff, we'll slow down just a little bit. So just like before, we're going to take special note of our argument list up here. We're still going to hold on to the value n. We're still going to worry about which row we're currently looking at, and we're still going to want to consider some given level here as an empty string. Now the most important thing, as usual, and we want to make sure we spend careful thought on this even if we are speeding through a recursion solution, we always want to make sure that we set up our base case correctly. So just like before, we're still going to watch for when row is equal to n. If row is equal to n, that means we're all done with recursion. We need to return and stop calling pyramid anymore. Now, note that row is still equal to n here because n ultimately was really describing the number of rows we want. In the last video, when we spent some amount of time figuring out how to calculate the number of squares going this way right here, that was all about calculating the column direction. So row is still always going to be at a maximum of 3. It's the width of this thing that's going to start to change in nature. Speaking of which, that's going to be relevant right now because the next if statement that we're going to put together is going to detect when we are at the end of a level. So at the very right-hand side over here. Remember, the maximum column length, or the maximum number of columns that we can have in a row, is determined by the calculation 2 times n minus 1. So essentially, we want to check to see when our string, the level string, has a length of 2 times n minus 1. If we are at that length, then it's time for us to console log the level and move on to the next row. So we'll say if level.length is equal to 2 times n minus 1, then we need to console log the current level and move on to the next row. So we'll call pyramid with n. We'll increment row by 1, and note that we are definitely going to place the return statement here to make sure that we don't do any other work inside this function. Okay, so that's looking good. Now the last third to this thing is where things start to get a little bit more hairy. Remember that the last third here is really intended to decide whether or not we need to add a space or a pound to the level string. Now previously we had that very simple calculation to worry about. All we had to worry about was if the length of our string was less than or equal to row. But this time around, just like we had to kind of struggle a little bit with the iterative solution, this time around we have to again calculate that midpoint and then decide if the current element that we're considering is within that range of the midpoint. So just like before, and I know the description on this was a little bit challenging, but we still want to do this kind of midpoint calculation. We want to consider the row that we're on and then mark every element that's within some range of that, like plus or minus some amount, to be a pound. Otherwise, it should be a space. So let's look at the math for this. First, we'll calculate the midpoint, which will be math.floor, 2 times n minus 1. And then in another, outside of this first set of parentheses right here, remember order of operations, we'll divide by 2. So that will give us our midpoint index. Next, we're going to put together an if statement to decide whether or not we're going to add on a pound or a space. Now, rather than do our actual function call to the next pyramid call inside the if statement, I'm going to make a temporary variable called add. Add is going to contain the character that we're supposed to add to our level string. It'll make sense in just a second when we put down this if statement. So we'll say if, and this is the nasty part, so pretty big comparison we got here, if midpoint minus row is less than or equal to level dot length. So remember, in the recursive solution, we determine which column we are currently operating on by looking at the length of our level string. So if the length of the level string is less than or equal to, or excuse me, greater than or equal to the difference between midpoint or row, so that would essentially take care of making sure that we are, on the right-hand side of this barrier right here. And then we'll do the opposite side as well. So, and if midpoint plus row is greater than or equal to level.length, then we will add in a pound. So the second portion of the and statement over here, so this portion right here, is making sure that we're still to the left of this bound right here. Okay, so now we're going to decide which character to add, or I should say we just did. We're going to assign the character that we should add to the variable add. So in that case, it's going to be pound. Otherwise, we want to get a space in there. And of course, do make sure that this is a space character, not an empty string. So that's, by the way, why we use this temporary variable add right here. So just to assign the character that we should add in. And then down underneath all this stuff that's going on right here, we will then start off our next call to pyramid. So pyramid, n is always going to be unchanged. We are not going to change row because we are still in the middle of a row here on this bottom third. And then the last part, we're going to make sure that we take this new character that we just generated and add it on to our level string. So we'll say level plus add, like so. Whew, tough one. Let's save this, check our terminal. Looks like I completely forgot to start up my tests. Let me start these back up and we'll see how we're doing. All right, 4 tests passing out of 4. Not bad. Okay, so this has been our recursive solution. Again, this was pretty good practice because we got to see kind of a more straightforward application of it with the steps problem, and then we got to redo it over here with pyramid, but with some added complexity on top. Both these problems, I know I say this all the time throughout this course. I know I've said, oh yeah, this is a real common problem, but again, all the problems I picked for the course are, of course, common problems that I really do expect you to see in an interview. And so problems like this one right here that are kind of concerned with spatial things and laying out objects and spaces or whatever it is, common interview questions that you'll see, even though, yeah, of course, no one in front-end engineering ever is going to do some stuff like this. Yeah, I know, that's a totally separate discussion that we haven't really touched on in this course. I know that most of these questions are totally bogus and not relevant to a real job at all, but that's just life. We could talk for hours about that. Anyways, this has been our recursive solution. Let's move on to our next problem in the next section. So I'll see you there.